KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Functions topic. Already we discussed constant function, okay, and polynomial function. Next function is a rational function. In rational function, we'll get functions of the form f of x upon g of x, where f of x and g of x are polynomial functions in x. Okay, functions of the form f of x upon g of x, where f of x and g of x are polynomials of x. Okay, defined in a common domain, where denominator is not equal to 0, where g of x is not equal to 0. Okay, something like this. F of x is equal to x square plus 3x plus 2 upon x minus 1, for example. Okay, rational functions are functions of the form f of x upon g of x, where f of x and g of x are polynomial functions of x. Okay, but g of x is not equal to 0. Next one is a modulus function. These are important: modulus function, signum function, greatest integer functions. Okay, modulus function, a function defined by a function f from R to R, means the domain is all real numbers and the codomain is also all real numbers, defined by f of x equal to modulus of x. F of x equal to modulus of x for every real number is called modulus function. A modulus function or absolute value function, it gives magnitude. It gives magnitude. Now example, now modulus of 2 is what? 2. Modulus of minus 2, magnitude wise 2. Okay, number only will write. Okay, so modulus of 1.5 is 1.5, modulus of minus 1.5 is also 1.5, modulus of 0 is 0, modulus of 5 is 5, modulus of minus 5 is also 5. So when you give negative number or positive number, in the end you get a positive number only, greater than or equal to 0. Okay, so here how we will write is modulus of 2 directly wrote 2. Modulus of minus 2 you wrote, what you wrote? What is the answer? 2 we wrote. It is nothing but negative of this negative number. Negative of this negative number. Now modulus of 1.5, modulus of 1.5 is how much? 1.5. Modulus of minus 1.5 is 1.5. Nothing but negative of this negative number. Negative of minus 1.5. Okay, minus of minus 1.5 is plus 1.5. Modulus of 0 is 0. Okay, modulus of 5, whenever inside quantity is positive, we'll write directly that number. Whenever inside the modulus is negative, we'll write negative of that number. Okay, modulus of minus 5 is minus of minus 5. Okay, so modulus of x is defined like this: modulus of x is equal to x whenever x greater than or equal to 0. Okay, modulus of x is minus x when x less than 0. So modulus of x, suppose inside quantity is positive, greater than or equal to 0. Suppose inside quantity is non-negative, directly we will write that number. Suppose inside modulus is a negative number, what we will write? Negative of that number. Negative of negative number. Okay, so modulus of x is equal to x when x greater than or equal to 0. Modulus of x is minus x when x less than 0. So modulus of 2, Modulus of 2 is what? 2. Directly we write as 2. Modulus of minus 2. Modulus of minus 2 is what? Minus of minus 2. Minus of minus 2 plus 2. Okay. Modulus of 1.5 is what? 1.5. Modulus of minus 1.5 is modulus of minus 1.5 is minus of minus 1.5. Okay. A mod x function is defined as modulus of x is equal to x when x greater than or equal to 0. Modulus of x is minus x when x less than 0. Okay. Graph is like this, rough graph. Okay. Suppose x positive, modulus of x is what? X. Okay, so y is equal to mod x, nothing but y is equal to x for x greater than or equal to 0. Suppose modulus of 1 is what? 1. Modulus of 2 is what? 2. Modulus of 3 is what? 3. Modulus of 4 is what? 4. Okay, so it is nothing but like this. Okay, this is y is equal to x line. Okay, y is equal to x line, 0 to infinity, y is equal to x line. Okay, suppose x is 1, modulus of 1 is 1. X is 2, modulus of 2 is 2, x is 3, modulus of 3 is 3, x is 4, modulus of 4 is 4. Okay, like this. Suppose here if you write minus 1, modulus of minus 1 is what? Modulus of minus 1 is 1. Okay, so ordered pair is nothing but minus 1 comma 1. Okay, suppose modulus of minus 2, modulus of minus 2 is what? 2. So minus 2 comma 2. Okay, minus 3 comma 3. Minus 4 comma 4. Okay, so it is nothing but the line y is equal to minus x, y is equal to minus x, y is equal to minus x. Now while discussing functions, you have to know rough graph of the function, what is the domain of the function and what is the range of the function. Domain of the function means what values we can give for the function, what values we can give for the function, what values we can give. Okay, range of the function is what function is giving by giving different values for the variable. Now here what values we can give for x. Now here observe here, domain you can check where the graph. Okay, domain it is nothing but x values, range nothing but y values. Okay, now x values, now graph is in first quadrant and second quadrant. No, in first quadrant x positive, in second quadrant x negative. So you can give x values anything. So domain of the function is what? All real numbers. Domain of the function is all real numbers. Okay, now graph is in first and second quadrant. In first and second quadrant y ordinate positive, in first quadrant y ordinate positive, in second quadrant is also y ordinate positive. So range is what? Range is minimum value 0, maximum value up to infinity. So range of this function is closed interval 0 to infinity, nothing but non-negative real numbers, non-negative real numbers. That is modulus function. Okay, a mod function is defined as modulus of x is equal to x when x greater than or equal to 0, minus x when x less than 0. Okay, means inside quantity is non-negative, we'll write directly that number. Suppose inside the modulus quantity is negative, we'll write negative of that number. Okay, here examples given, modulus of 2 is 2, modulus of minus 2 is 2, nothing but negative of this minus 2. Okay, modulus of 1.5 is 1.5, modulus of minus 1.5 is minus of minus 1.5. Okay, modulus of 0 is 0, modulus of 5 is 5, modulus of minus 5 is 5, nothing but minus of minus 5. Okay, next function, Signum function. Next one, Signum function. A Signum function, a function f from R to R defined by, here these are real functions. Okay, a function f from R to R defined by f of x is equal to 1 for x positive, f of x equal to 0 for x equal to 0, f of x equal to minus 1 for x negative. How it is defined? F of x is equal to 1 for x positive. Okay, f of x equal to 0 for x is equal to 0, f of x is equal to minus 1 for x less than 0 is called Signum function. Means f of 1, f of 1 is 1, f of 2 is 1, f of 3 is 1, f of 10 is 1, f of 100 is 1, f of 1000 is 1, f of 10,000 is 1, f of million is 1. Okay, suppose x quantity is positive, okay, you get 1. Suppose x is 0, f of 0 is what? 0. Okay, f of negative means f of minus 1 is minus 1, f of minus 2 is minus 1, f of minus 3 is minus 1, f of minus 10 is minus 1, f of minus 100 is minus 1, f of minus 1000 is minus 1. Okay, now function of this form is called Signum function. Means when x value positive, you will get f of x as 1. If x value negative, you get f of x as minus 1. Okay, if x value 0, you get 0. Okay, this kind of function is called Signum function. Okay, we will define like this. Actually, f of x, Signum function definition is like this. Like we have f of x equal to mod x. Signum function f of x is equal to mod x by x for x not equal to 0, 0 for x is equal to 0. Okay, now mod x by x. Mod x by x, again what you can write for x positive and x negative case you can write, no? Anyhow x equal to 0, f of x is 0, that is defined. Now x positive. Now x positive, mod x is what? In modulus function we discussed, when x positive, mod x is x. So x by x is 1. For x negative, in case of x negative, mod x is what? Minus x. So minus x by x, minus 1. Actual definition of Signum function is this one, f of x equal to mod x by x, for x not equal to 0, 0 for x is equal to 0. Okay, means for x positive mod x is x, so x by x is 1. Okay, so f of x is equal to 1 for x positive and f of x equal to 0 for x 0. For f of x, for x negative mod x is what? Minus x, numerator minus x, denominator x, x cancel, minus 1. So f of x is equal to minus 1 for x less than 0. Okay, this is the function, Signum function. Okay, the graph of Signum function is like this. Graph of Signum function is like this. For 0, you get 0. Okay, for x positive, y value is 1. For x positive, y value is 1. For x negative, y value is minus 1. For x negative, y value is minus 1. Okay, now here if you observe, for x positive get y value as 1, for x negative y value minus 1, for x 0 y value 0. Now if you observe, it is defined for all real numbers. No? It is defined for all real numbers. So domain of the function is all real numbers. Domain of the Signum function is all real numbers. But range of the Signum function is only 3 values, that is minus 1, 0 and 1. Okay, when x is positive, Signum function gives 1. When x is negative, Signum function gives minus 1. When x is 0, Signum function gives 0. Okay, so domain of the Signum function is all real numbers. Range of the Signum function is only 3 numbers, minus 1, 0 and 1. Okay, now here example I give, Signum of 2 is what? 1. Signum of minus 2 is what? Minus 1. Signum of 3 is how much? 1. Signum of 10 is how much? 1. Signum of 100 is how much? 1. Signum of 1000 is how much? 1. Okay, Signum of minus 3, minus 1. Signum of minus 5, minus 1. Signum of minus 10, minus 1. Signum of minus 100, minus 1. So Signum function for positive values it gives 1, for negative values it gives minus 1, for 0 it gives 0. Okay, that is Signum function. Okay, next, greatest integer function. Greatest integer function. But before going to greatest integer function, we'll discuss this part once. Okay, we'll discuss this part once. Okay, now any real number we can write it as sum of integral part plus fraction part. Sum of integral part plus fraction part. Okay, fraction part always lies between 0 to 1. Always lies between 0 to 1. Okay, always lies between 0 to 1. Every real number we can write it as sum of integral part plus fraction part. Okay, fraction part always lies between 0 to 1. Closed interval 0 to open interval 1. Okay, Now for example 1.25, 1.25 what we can write, 1 plus 0.25, 1 plus 0.25. Here integer part is 1 and fractional part is 0.25. Now 2.7 is 2 plus 0.7. So 2 is integral part, 0.7 is fractional part. Okay, fractional part is always greater than or equal to 0 and less than 1. Okay, next minus 1.3, minus 1.3 you can say it as minus 1 minus 0.3, that we can write, but standard form is minus 1.3 is nothing but minus 2 plus 0.7. So in minus 1.3 integer part is minus 2, fractional part is 0.7. This is important, minus 1.3, what we can write, minus 2 plus 0.7. So here integer part is minus 2, fractional part is 0.7. Okay, minus 3.5, what we can write, minus 4 plus 0.5, minus 4 plus 0.5. Okay, minus 3.5 we can write as minus 4 plus 0.5. Okay, now minus 0.7, we can write as minus 1 plus 0.3. So here in integral part is minus 1, fractional part is 0.3. 5 is nothing but 5 plus 0.0. Here integer part is 5 and fractional part is 0. Okay, so every real number we can write as sum of integral part plus fraction part. Okay, now come to greatest integer function. A function f from R to R defined by f of x equal to, this is greatest integer symbol, greatest integer of x. Okay, for every real number assumes the value of the greatest integer less than or equal to x. F of x equal to greatest integer of x assumes the value of greatest integer less than or equal to x. Okay, now what is it meaning? What is it meaning is, now if you write greatest integer of 1.25, greatest integer of 1.25, here integral part is how much? 1. Integral part is 1. So greatest integer of 1.25 is 1. Okay, next greatest integer of 2.7 is 2. Greatest integer of minus 1.3 is nothing but minus 2, not minus 1. Okay, greatest integer value, greatest integer function value, greatest integer of x is nothing but value of the greatest integer less than or equal to x. Okay, so greatest integer of minus 3.5, greatest integer of minus 3.5 is minus 4. Greatest integer of minus 0.7, nothing but minus 1. Greatest integer of 5 is 5. Okay, like that. Now what is it meaning is, greatest integer of x, some examples I gave here, greatest integer of x is minus 2 whenever this inside x value lies between minus 2 to 1, minus 2 included, minus 1 excluded, means minus 1.3, greatest integer of minus 1.3 is what? Minus 2. Greatest integer of minus 1.5 is what? Minus 2. Greatest integer of minus 1.7 is what? Minus 2. Like that. Okay, greatest integer of x is minus 1 for x lying between minus 1 to 0, minus 1 included, 0 excluded, means greatest integer of minus 1 is minus 1, greatest integer of minus 0.5 is minus 1, greatest integer of minus 0.7 is minus 1, like that. Okay, greatest integer of x is 0 when x lies between 0 to 1, 0 included, 1 excluded, means if you consider greatest integer of 0.5, greatest integer of 0.5 is 0, greatest integer of 0.7, 0, greatest integer of 0.8, 0, okay, greatest integer of 0.9, 0, greatest integer of 0.9999999, that is also 0, okay, like that. Now greatest integer of x is 1 when x lies between 1 to 2, 1 included, 2 excluded. Means greatest integer of 1 is 1, greatest integer of 1.2 is 1, greatest integer of 1.3 is 1, greatest integer of 1.7 is 1, greatest integer of 1.9 is 1, greatest integer of 1.9999 is also 1. Okay, like that we'll write. But this is the graph. This is the graph. Means 0 to 1 any number you take, greatest integer value is 0. Okay, 1 to 2 any number you take, its greatest integer value is 1. Okay, 2 to 3 means 2 included, 3 excluded, greatest integer value is 2. Okay, 3 to 4, 3 included, 4 excluded, greatest integer value is 3. Okay, minus 1 to 0, any number you take, its greatest integer value is minus 1. Okay, minus 2 to 1, minus 2 to minus 1, minus 2 included, minus 1 excluded, greatest integer value is minus 2. Like this we'll write. Okay, but here domain of the function, here it is defined for all real numbers. It is defined for all real numbers. So domain of the function is all real numbers. Okay, greatest integer function is defined for all real numbers. Okay, domain is all real numbers. Now what is the range? Now if you observe here, what you are getting output as minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7 and so on. What you will get? You will get output or range as integers. Okay, so domain of greatest integer function is all real numbers, range of greatest integer functions is only integers. Now here you can observe, okay, some examples. You get minus 3, minus 5, minus 10, 0, 1, 2, 3, 4, 5. Okay, you get output or result of greatest integer is a integer. Okay, concept algebra of real functions. Algebra means addition of two real functions, subtraction, scalar multiplication, multiplication of two real functions and quotient of two real functions. Okay, we'll discuss here. First one, addition of two real functions. Addition of two real functions. Let f from x to r and g from x to r be two functions. Okay, where x is subset of r, means x and x is a subset of real number set. Okay, f and g be two real functions. Okay, then addition of two functions f plus g from x to r defined by f plus g of x is equal to f of x plus g of x for every x belongs to x. Addition of two real functions f from x to r, g from x to r be two real functions. Okay, where x is a subset of real number set. Then sum of the two functions f and g, f plus g from x to r defined by, how we defined, f plus g of x is equal to f of x plus g of x for every x belongs to r. Okay, but next subtraction. Subtraction is also similar. In place of plus we'll have minus f from x to r and g from x to r be two functions where x is a subset of r. Then we defined f minus g from x to r by f minus g of x is equal to f of x minus g of x for every x belongs to capital X. Okay, this is subtraction. Next, multiplication of a function by a scalar. Multiplication of function by a scalar. Now f be a real function and a alpha be a scalar. Scalar means just a real number, any real number. Then the product alpha f. Product alpha f is a function from x to r. Okay, how it is defined? It is defined by alpha f of x is equal to alpha into f of x for every x belongs to r. Here alpha is any real number, any real number. Okay, so multiplication by a scalar. Okay, alpha f of x is equal to alpha into f of x for every x belongs to r. Okay, next, multiplication of two real functions. Multiplication of two real functions. My f from x to r and g from x to r be two real functions. Okay, f from x to r and g from x to r be two real functions, and multiplication of these two functions fg from x to r defined by fg of x is equal to f of x into g of x for every x belongs to x. Fg of x is equal to f of x into g of x for every x belongs to x. Okay, this is multiplication of two real functions. How it is defined? fg of x is equal to f into g of x is equal to f of x into g of x for every x belongs to x. But this is also called pointwise multiplication. Okay, pointwise multiplication. Okay, next quotient f from x to r and g from x to r be two real functions. The quotient f by g is denoted by f by g and defined by f by g of x is equal to f of x upon g of x, f of x upon g of x, provided g of x is not equal to 0. Now quotient is defined when denominator is non-zero. Okay, f of x upon g of x provided g of x is not equal to 0. But these are algebraic operations: addition of two real functions, subtraction of two real function, multiplication of a function by a scalar, multiplication of two real functions, and quotient of two real functions. Okay, f plus g of x equal to what we'll write? F of x plus g of x, f minus g of x equal to f of x minus g of x, and alpha f of x is equal to alpha into f of x, and fg of x is equal to f into g of x equal to f of x into g of x, and quotient f by g of x is equal to f of x upon g of x. Okay, these are algebraic operations. Now we will discuss some examples and exercise problems. Okay, now let f of x equal to x square. Function f of x is x square and g of x is 2x plus 1. How functions are defined? F of x is defined as x square and g of x is defined as 2x plus 1. Be two real functions. Find f plus g of x, f minus g of x, f into g of x, f by g of x. Now f plus g of x, f plus g of x is what? F of x plus g of x, f of x plus g of x. What is f of x? X square. Plus what is g of x? 2x plus 1. So x square plus 2x plus 1. Okay, next f minus g of x, f minus g of x, f minus g of x, how it is defined? F of x minus g of x. Now f of x is x square minus g of x is what? Minus 2x plus 1. So minus of 2x plus 1 is nothing but minus 2x minus 1. Okay, this is f minus g of x. Okay, fg of x, f into g of x is equal to f of x into g of x. What is f of x ma? F of x is x square, g of x is 2x plus 1. So multiply x square inside, 2x cube plus x square, 2x cube plus x square. Next, f by g of x, f by g of x is what? F of x upon g of x. Okay, what is f of x? X square, g of x is 2x plus 1. This f by g quotient is defined when denominator is non-zero. Denominator is non-zero means 2x plus 1 should not be 0, means x should not be equal to minus 1 by 2. Suppose x is equal to minus 1 by 2, this denominator is 0. So f by g of x is defined for x not equal to minus 1 by 2. Now here f plus g, f minus g, fg defined for all real numbers, but the quotient f by g of x is defined for all real numbers except x is equal to minus 1 by 2. Okay, because denominator should not be 0, 2x plus 1 should not be 0 means x is not equal to minus 1 by 2. Okay, this function is defined for all real numbers except x is equal to minus 1 by 2. Okay, that's it. Next, f of x is equal to square root of x, f of x is equal to square root of x, g of x is equal to x be two functions defined over set of non-negative real numbers. The previous example be two real functions. Two real functions means x can be positive real number, negative real number, 0, anything. But here these two functions defined over set of non-negative real numbers. Set of non-negative real numbers. Why it is defined over set of non-negative real numbers is, now g of x equal to x, here domain of the function is all real numbers. You can give x value positive, negative, 0, anything, no issue. G of x domain is all real numbers. But f of x is what? Square root of x. Now square root of x, suppose x is equal to minus 2. Square root of minus 2 is not a real number, it is an imaginary number. Functions are real numbers means values has to be real. So this function is defined, f of x is defined only for non-negative real numbers. It is not defined for all real numbers. F of x is not defined for all real numbers. It is defined only for non-negative real numbers. So f of x domain is non-negative real numbers. G of x domain is all real numbers. In such case, when you write f plus g, f minus g, f into g quotient, okay, that has to be defined on common domain. What is common domain? Common domain is non-negative real numbers. Okay, so these two functions are defined over set of non-negative real numbers. Then we have to find f plus g of x, f minus g of x, f g of x into and f by g of x. Okay, now f plus g of x. F plus g of x is what? F of x plus g of x. What is f of x? Square root of x. G of x is x. Square root of x plus x. That is f plus g of x. Now f minus g of x. F minus g of x is f of x minus g of x, where f of x is equal to square root of x minus g of x is minus x. So f minus g of x is what? Square root of x minus x. Okay. F into g of x. F into g of x is what? F of x into g of x, where f of x is square root of x, g of x is x. X means x power 1, square root of x means x power 1 by 2. So x power 1 into x power 1 by 2, bases are equal, you can add power. So 1 plus 1 by 2 is 3 by 2. So x power 3 by 2. F into g of x is equal to x power 3 by 2. Okay. Next, f by g of x. F by g of x is what? F of x upon g of x. So f of x is how much? Square root of x. G of x is how much? X. So square root of x upon x. But denominator x we can write as root x into root x. So root x in numerator, root x in denominator cancel. So still we have root x in denominator, means x power 1 by 2 in denominator. So x power 1 by 2 in denominator, if you write in numerator, x power minus 1 by 2. Okay, it is nothing but 1 by square root of x. Here x is not equal to 0. Here x is not equal to 0, because if x is 0, 1 by root of 0 is undefined quantity. Okay, so this function is defined, f by g of x is defined when x is not equal to 0, means only positive real numbers f by g of x is defined. Okay, now here f plus g of x is equal to f of x plus g of x, root x plus x. F minus g of x equal to root x minus x. F into g of x equal to root x into x, nothing but x power 3 by 2. F by g of x is f of x upon g of x, root x by x, nothing but x power minus 1 by 2. Okay, x power minus 1 by 2. Here x is not equal to 0. Okay, some more example problems and next exercise will start in next session.